Nope. Guess I have to swap displays, don't I? Yeah. That's a little better. Good afternoon, everyone. Here's a real-time scenario. You have a web application, customer portal, that your company has spent months developing. And it's just been compromised. Customer information is leaked, exposed for your competitors to laugh at and your customers to worry about. How could this have happened? You've done all the right things. You were good soldiers. You did static analysis, looking for technical issues in the source code. You performed dynamic analysis, trying to hack into the web app itself, looking for SQL injection, cross-site scripting, those types of things. You have manual code reviews at your company, tons and tons of continuous integration, mountains of QA and automation. How could this have happened? More importantly, why did it happen by an automated bot that had no idea what your application does? My name is Steve Springett. I'm an application security engineer for Axway. And I spend an enormous amount of my time educating developers around the world. We have 7 development offices around the globe. Spend a lot of my time educating developers on the principles of writing secure software, secure architecture, so that when Axway develops products and releases it out to the market, our customers are confident in our ability to deliver something secure. So I was actually in Bulgaria this week, and it was a great opportunity to speak at this conference as well. I'm a software engineer by trade. Been doing this for a couple decades. Over the last 4 years or so, security has definitely been a full-time job. There's just a lot of issues. Has anyone heard that this year is supposedly the year of the breach? This is the decade of the breach. My credit card has been compromised 3 times in 1 year. So I'm involved in a couple open source projects as well. OWASP Dependency-Track, of which I'm a project lead on. I'll talk about that a little bit at the end. But my primary focus today is talking about automation of vulnerability detection and dependencies, and I'm a contributor to OWASP Dependency-Check. So what is the history of the problem? As software engineers in the security space, we've always been aware that when we consume other people's libraries and frameworks into our own, that we are increasing the attack surface of our application. We're exposing it in ways that our developers didn't write, but it's out there. Additional upload functionality, web services interfaces, web servers. How many of you actually have written your own persistence layer XML parser, web services, RESTful library? There's not a whole lot of reason to do this. Modern applications are consumed and built using open source components or other components that might have developed ourselves. But we try not to reinvent the wheel, because reinventing the wheel is very expensive. But when we reuse other people's code, ultimately we have to take responsibility for that code. So we've always known it was an issue. And in 2012, CEO of Aspect Security, Jeff Williams, and his team set out to do a study to see if our assumptions about this problem was correct or not. And what they did is they analyzed Maven Central. And Central is, for the Java people in the room, a Uber repository for all libraries and frameworks in the Java world. If it's been developed in the last 10 years, good chances are it's on Central. So what they did is they analyzed 31 of the most popular libraries and frameworks. These are things like Struts, Hibernate, Spring Framework, Google Web Toolkit, etc. They analyzed these libraries, 113 million downloads worth, and concluded that 26% of all requests to Central, 26%, were for things that had known vulnerabilities in them. Now, why in the world would a developer ask for something that is going to introduce a bunch of defects or vulnerabilities into their code? Probably because they didn't know about it. All right? When I'm developing code, my IDE tells me if I'm using a deprecated method or if I'm using a loop that might, have performance issues. My IDE does not tell me that I'm using an old version of Spring Framework that has 5 different vulnerabilities, several of them high. It doesn't do that. Visibility is a problem. As a developer, I just asked for a library in my POM, or check something into Ant, into the version control system, without really understanding the technical risk of what it is I'm doing. The study also concluded that either the open source community is far superior to everyone else in terms of their defect to code ratio, or more than likely that most vulnerabilities are yet to be discovered. In 2014, 2 years later, they basically did the same study, sister company of Aspect Security called Contrast Security, still Jeff Williams' team. Same results. However, we haven't progressed at all in 2 years. Not at all. In fact, the new study concluded that 22%, only 22% of organizations have a policy in place to ban components that have known vulnerabilities. 22%. It's not a good number. As a result of Jeff Williams' team and his study, as a result of that, and as well as some other data points, a new entry was put into the OWASP Top 10. Now, the Top 10 is a top 10 list of web application vulnerabilities. It gets published every 3 years. It's definitely not a comprehensive list, but is a starting point. It's the most prevalent issues during that time. And number 9 on the list now is using components with known vulnerabilities. It's a widespread problem, it's far-reaching, and as we were mentioning, from a developer's perspective, it's difficult to detect. As a result of, so why should you care about this issue, right? It's not in your code. It's not in the code that you're testing. Cross-site scripting, denial of service, command, SQL, LDAP injection. I don't know about you, but these are things I really don't want in my application. Even an application as simple as this can be vulnerable. I can't tell you the number of programming books that I open and read over the last 5 years or so. And every single one of them, I have yet to come up with one, except for a security book, that actually doesn't contain vulnerable code in it. They all do, which is unfortunate. So as a result of being in the top 10, a new project was formed. OWASP has got a lot of projects that people like me and others contribute to. OWASP Dependency-Check. This was a project started by Jeremy Long, a security researcher and engineer for a large financial company in the United States. And Dependency-Check is open source. It's licensed under Apache 2.0 license. And it does two things, and two things really well. First and foremost, it identifies the components. What is it? Who made it? What version is it? What language was it written in? What license does it have? There's a lot of things about the components that we need to know. Many organizations have legal requirements in terms of licensing and just documenting the components that they're shipping with applications. So first and foremost, it does that, but we can do a lot more interesting things once we have this information, like using the National Vulnerability Database to see if there's any vulnerabilities against what we just identified. And then, if there is, let's create a report. That's what Dependency-Check does, and this is what it is available in. So there's a Ant plugin, Maven plugin. I'm the creator of the Jenkins plugin, and there's a command line interface as well that you can use to script in your. A lot of organizations use this for smoke test environments and that sort of thing. The URL to the project is at the bottom. If we were to look at the engine of Dependency-Check, first and foremost, it has to download a copy of the National Vulnerability Database. This is a free database. It's hosted by NIST, the National Institute of Standards and Technology in the United States. And once it has a local copy of NIST, and it indexes it, makes it searchable. It actually uses Lucene behind the scenes. Then we can scan the files on the file system, looking for things that we can start to analyze, like the jars and wars and Rs and DLLs and EXEs and these sorts of things. The analyzers themselves, there's a small little API that you can use to create your own analyzers. So if you have an internal storage repository for keeping your libraries somewhere, or if you have a new file format that you want to be able to scan, it's very simple to create your own analyzers. And then once we have collected the evidence, once the analyzers have done their job, then it's just a matter of querying the National Vulnerability Database, the local copy, and creating a report. If we were to look at the analyzers themselves, there's several analyzers within Dependency-Check. There's archive analyzers to look at zips and APKs for Android, targzs, wars, Rs. There's a .NET assembly analyzer that looks at DLLs and EXEs. A jar analyzer for all the Java archives. There's a server-side JavaScript for Node.js. For libraries that are in the same form that when you downloaded them from Maven Central, so they have the same SHA-1 hash. There's a SHA-1 hash comparator for Maven Central and for an organization's internal Nexus Pro server. So if you have your own little internal Maven repository servers, we can scan those as well. NewSpec NuGet analyzer. Once we've actually collected all of the evidence, again, this is file names and package names, who made it, what version, then we can query the National Vulnerability Database. There's a couple different analyzers for that, NIST specific, to kind of figure out what it is we're querying on. And then it also has suppression files because dependency check is evidence-based, not factual-based. It's evidence-based. We use the evidence the best way possible. There is a potential for false positives. The National Vulnerability Database does not catalog components. So, what does that mean? If you were to scan the MySQL JDBC jar in Java, version 5.1. Whatever the latest version is. Well, since the National Vulnerability Database doesn't catalog components, just the higher level applications, you would also come up with all of the vulnerabilities for MySQL Server 5.1. Whatever, which is going to be a lot of them. So we have a suppression analyzer. Let's see a very simple scenario of a dependency check scan. I don't think my video is going to play, is it? No. I actually pre-recorded this. I have another live demo that I'll share with you. This is a recorded demo. I have a workspace with a single directory in that workspace that I want to scan. So I'm going to scan the lib directory. The lib directory contains 100 components, 100 jars that I want to scan. In this particular case, it's a vulnerable online banking application. 100 jars. So I run dependency check with a couple different arguments. One, just to give it a name. And two, the second option is just to specify the lib directory. So right now, it's analyzing all 100 jars. And it takes about 20-25 seconds or so. The first time you run dependency check, it has to download the National Vulnerability Database locally and make it indexable. It usually takes about a minute or two. Once you actually have it locally, it only updates whenever necessary. So it looks like the analysis is complete, and I'm left with an HTML file that I'm going to open up. And you'll see right there that I've actually analyzed 100 dependencies, and I found 6 of which contain vulnerabilities, 11 vulnerabilities total. Clicking on one of them, in this case Apache Commons file upload 1.3, and expand the evidence, I actually see all the evidence that was used to determine what that jar actually was. Scrolling down further, I see a list of all the vulnerabilities associated with that, and all the evidence that points to external links. So dependency check in its simplest form is that a utility that you can execute against jars, DLLs, EXEs, any supported component to get a list of vulnerabilities that it believes you are vulnerable to. Jenkins plugin. This is something I'm hopefully familiar with since I wrote it. Hopefully, right? Node agnostic execution. In Axway, we've got, I don't know, 3 master servers, something like that. We've got about 40 slaves. So it was very important for us to be node agnostics because our master servers, they don't really run anything. They just are the scheduler. Got per build results. So from build to build, we actually keep track of the number of vulnerabilities, number of total, as well as critical, high, medium, lows. And once we're keeping track of per build results and the severity of those, we can do some more interesting things like graph give development managers something to point to. But we can also do more constructive things like break the build, right? We talked about the fact that developers don't have any real insight into this problem, which is why this problem is perpetuating. So we can break the build. Developer checks in a dependency, he adds a dependency to the POM, commits it, Jenkins fires off, boom. You get a warning build or a failed build, however you configure it. It has a flexible publisher mechanism. So what does that mean? Well, you can use the Ant, Maven, or command line interface to perform the analysis to get the result. That's one way. You can also use Jenkins itself to perform the scan, as well as to visualize the results. So it's very flexible in that regard. Since this is a conference dedicated toward automation, I put together a typical scenario. Axway uses something nearly identical to this. So we're using Jenkins for continuous integration, obviously, with the Dependency-Check plugin installed. We also have a ThreadFix plugin installed, and let me just pause for a moment here and talk about ThreadFix, because it's extremely important to the security industry as a whole, and to Axway actually for continuous security work. ThreadFix is a vulnerability aggregation platform. One of the presenters before me talked about some of the security tools that they were running. Z-Attack Proxy, Burp Suite, Nessus, all these other things. Lots and lots of security tools out there. What you can do with ThreadFix is no matter what tool generated the results, you can upload it to ThreadFix. ThreadFix automatically knows what to do with it. It knows all these different file formats. It supports like 30 or 40 of them. And there's more being written all the time. And as a security vulnerability, it's a defect by its very definition, right? But it's a special type of vulnerability. It's a special type of defect. It needs to be triaged a little bit differently than a performance issue, for example. So ThreadFix gives us a platform to do that, which also ties into a defect tracker. So this is the scenario that I'll automate. There's only one decision in this entire thing. So from our version control system, or file system, whatever, we run the Jenkins Dependency-Check plugin. The results of the analysis get posted automatically to ThreadFix, where my risk assessment team, my security team, can take a look at it to determine whether or not, yes, this is something that needs to be fixed, or no, it really doesn't. And then from there, it goes directly into our bug tracker. So not only do we have visibility to the developer in Jenkins, but we have visibility to the developer in our defect tracker as well. Okay, so I have a Jenkins install locally, and again, it's my online banking application. This is actually an application that HP developed many, many years ago. That is a vulnerable banking application, much like you would do your online banking at home. This is vulnerable by design. It's a teaching tool, right? Hopefully no bank uses this in production. So I'm going to start. I've got a couple different builds here. I've got my main build up at the top. I've got another build just like it, but executing on a slave. And then I've got a dependency check build as well, right? Very simple scenario. So I'm going to kick off a build. Let's go to my build here. Go to the console output so you can see what it's doing. So as you can see, it's analyzing the dependencies here at the bottom. And in a few moments, it'll tell me how many issues it found and upload the results automatically to my vulnerability aggregation system. There's nothing really I have to do. Live demos. I should mention that on non-Windows platforms, reminded by the monopath that's in here, on non-Windows platforms, Linux, Mac OS, the analyzer actually works with mono. So you can install your MDK locally, point to the MDK directory, and you can analyze .NET assemblies on non-Windows platforms. So my analysis complete. Found some issues, and the last step is that you see the upload was successful to ThreadFix. So let's look at, oof, that's not good. Somebody's doing something they shouldn't be doing. Yeah, I don't like to see upward trends. The developer did something. So it gives me this type of visual feedback. Now, if you're used to the looking at the Jenkins plugins for PMD, find bugs, those things, you'll notice that the interface is nearly identical. We actually use the exact same core libraries underneath. So we get all the details of what it is that you found, what types of issues, the actual vulnerabilities themselves, and then of course, you know, looking at your most critical ones first. Or in this case, I got some new ones, so I get to see that a developer checked in a new vulnerability or a new library. Looks like it's the Apache Axis 1.4, which has known issues. And yeah, okay. So this is the Jenkins plugin. If it was configured to break the build, have a warning build, my engineers would automatically be notified. My build engineer would probably be going over to the developer's cube with a baseball bat, whatever the case is. Fix it. Fix the build. But this is only part of the automation. If I were to look at the scan results in ThreadFix, we can go to my banking application. They are part of the red team because they are the truth seekers. I can go to my online banking application and see the results. Looks like I already filed a defect for this one. Somebody was using an old version of Spring Framework that has known vulnerabilities. But I can select another one of these. It's probably a bad one to choose. Let's choose this one here. Oh, here's one for OpenJPA. Yeah, that has a vulnerability in it. Come on, internet connection. Okay, give it a description. Submit the defect. So now I have successfully, completely automated my discovery of third-party vulnerabilities. I've made it visible to the developers. I've uploaded it to a system where my risk management, my security team, my executive part of R&D all have visibility into it. And with one decision, I've put it in the product backlog for the developers to fix, hopefully. So yeah, you get near real-time feedback with this type of mechanism. This is, again, this is what we basically use at Axway, which in a much grander scale. And what this does is that ensures that vulnerable components are not introduced in the development lifecycle as we develop our software. But it can also be used for products that are being sustained as well. Think about a product that you have a team that maybe works on it from time to time, maybe not full time. It's being sustained, maybe for a couple customers. Now, continuous integration provides us really the ability for looking at results from build to build, right? Developer checks in something, we get different results, right? Hopefully it doesn't break the build. Hopefully all the QA tests pass. With security, however, this is not necessarily true, right? We can get completely different results from day to day, and the code hasn't changed. Our knowledge of what was vulnerable yesterday is not the same as it is today. So for products being sustained, we can run this on a daily, weekly basis and get proactive warnings on any new issues that come up. A new vulnerability is discovered in struts. Fine, we'll get a notification of that. This issue, this type of environment is also being used not in a software development environment. Some companies are using Jenkins as a glorified cron job with reporting capabilities. Imagine Jenkins with the ability, with the Dependency-Check plugin, with the ability to scan the file systems on your enterprise's network, looking for the applications that you've written or purchased from other parties, looking for vulnerabilities in the products that you've deployed in your own infrastructure. It's actually being used by several companies in that regard as well. So what were the results? Well, we identified the vulnerable components during development, during continuous integration, continuous security. This is one minor thing that Axway does in our big overall continuous security initiative. Development team had visibility from the start. We uploaded the results to our aggregation system. Assessments could be made. Development team, again, has visibility because there's a defect tracker ticket with their name on it. And hopefully, by making this issue more out front, more out in the open, hopefully we can start to chisel away at this problem that has so far continued to grow despite all the evidence that we have that it's such a problem. So hopefully we can start to mitigate these types of issues. One related project, this is the project that I'm a leader of, is Dependency-Track. And think of it as an asset management application. It's a web-based app that you can record your dependencies, your components, your applications. What components are being used by what applications, and it actually uses Dependency-Check in the background to continuously run your analysis. So you don't even need a build system. You don't even need files because you're using the asset management application itself as the sole source of evidence for your national vulnerability database queries. So it's just another way for organizations to keep track of the vulnerable components that are being used. I've got a friend of mine who is he's the principal, so co-owner of a independent software company. They do a lot of custom work, so one-off applications for some pretty big customers. And they needed an application that kept track of all their components that they're using for all these different customers, right? So that way they can get proactive notification on, I have this application I developed for company A 1.5 years ago, and I just found out that yesterday that there's a new vulnerability against one of their components. Let me call that customer up and tell them about it, and I can get some more billable hours as a result. So anyway, that's Dependency-Track. It's a kind of a sister project to Dependency-Check and the whole Jenkins thing. So that's really all I have for today. Thank you very much. At this moment, if you have any questions. Don't be shy. I'll be hanging around the back if anyone does have any questions.
Okay,
So,
there was
okay.
a problem with the microphone because
Oh, okay, right
I had
on.
a question. It is interesting for me for this NIST database. Is it downloaded every time when you make a scan, or it's downloaded once, index it, and then you have to, I don't know, update it every once in a while when you decide to do so?
Right. So the first time that you run the tool, it will download the whole copy of the National Vulnerability Database, index it, make it searchable, that sort of thing. Once it's completely downloaded, then it just updates occasionally. And there's really nothing that you have to do to get that to work. There is another alternative. And this is actually what Axway does. We have an internal mirror of the NVD. So we actually mirror NIST. We mirror this data internally, so we don't have to go out to the internet to update every time. And that's actually an option in the Jenkins plugin as well.
Okay, thank you.
So imagine that we enable the Jenkins plugin for a very large project, and when we first started, I guess that everything will go just boom, with thousands or hundreds of vulnerabilities. So what we do in this case?
That's what ThreatFix is for. That's what looking at your results. Security vulnerabilities are a special type of vulnerability, right? It's a special type of defect. And in the case of, if you identify the MySQL driver, well, it will probably spit out about 100 vulnerabilities if you use it, because there's that many issues in the MySQL server. It's kind of the poster child for vulnerabilities. However, it's one of these things where, yeah, you might have a lot of issues. This has been a problem that has been kind of going under the radar for years, and even at Axway, we can't fix everything overnight, right? You got to incrementally make your product better. But like anything else, we treat each of the issues that we find and look at the severity. We look at how likely it is for that thing to be exploited, and what is the impact it's going to have if it does. And if it's going to be high on either one of those, it gets fixed right away. So you need to prioritize just like anything else. But you might find a lot of issues initially.
I have one question. How easy is it to maintain the vulnerability database? And the second question actually is, what is the process of doing that? Do you follow the security announcement by the vendors? Is there anything else that you do in order to keep it updated? Thanks.
What was the first question?
How easy is to maintain that vulnerability?
Maintain which database?
In terms of resources, is it 10 people taking care of that?
So in terms of the database, it kind of maintains itself. Now we Dependency-Check and the Dependency-Check plugin, it's kind of run ad hoc, right? We upload the results automatically to ThreadFix, and our teams are actually required, if they intend to release product, they are required to look at all of the issues of high, medium severity, that sort of thing, to determine whether or not something needs to be fixed. There's really nothing that needs to be maintained for that. So it's really not a lot of work, actually, which is great for me, because I'm actually helping 500 developers from a technical perspective, so I don't have a lot of time. Second part of the question, what was it again?
Second part was, what is the process you follow to update that database? Is it that you get updates from the security announcement from the vendors, or is it something else that you need additionally? Thank you.
Right. So the process of triaging the issues, right? Because again, security issues are a special kind of quality defect. The issue is really involving in triaging. So figuring out whether or not the component being used is actually vulnerable or not. Sometimes there will be false positives. Sometimes you've identified a vulnerable component and it really is vulnerable. But the line of code, that part of the component, maybe you're not using. So maybe it's okay in your application, at least for this version. Ensuring that your future versions remain vulnerable with that same component is a different challenge, and we really haven't figured that out yet. But we really encourage our development teams to upgrade their components on a very consistent basis. Now, this kind of goes against a lot of the things that we traditionally test for, right? We test for, in a sprint, we might have a few new features, and we retest those features. We constantly have a backlog of new features. What is challenging is getting the backlog for updating a component for a feature that already works, right? Because it might have a vulnerability in it. That's challenging. The easy way that we've found to mitigate that is that we have, Axway does a number of data flow type products that we sell into major governments of the world, financial institutions, a lot of big companies, right? And we have customers that flat out refuse to accept libraries that are so many years old, right? Security researchers typically do not look for vulnerabilities in really old stuff, like 5 years old or so. So we also have a policy that we update our components regardless of whether or not they have any issues or not. So that's something we are rolling out now, and that's definitely a challenge that we've been facing the last few years. So hopefully that answers your question.
In cases where you have a pretty big open source project and you use it, but only for something small, let's say 2-3 methods, you kind of inherit all the issues that are in the database for this particular open source project. Now, how would you go about that? Because probably some of them or most of them will be false positive. How to, I don't know, at least from your experience, how do you address this and find them in the fastest possible way?
So when you generate the, and I kind of glossed over the fact, but when you generate the HTML report for Dependency-Check, there's an optional thing right next to each finding. You can suppress the actual finding, and it's just a mouse click, and it gives you the XML that you need to create a suppression file. You can do that, or you can suppress the entire jar itself. So you can suppress per issue, you can suppress severities, it's really flexible how you want to suppress that. The next time you run a scan, then it will look at your suppression file and ignore anything that's being suppressed.
And thank you. And one more thing, do you know that if Threadfix supports FPR files from Fortify.
Fortify? Yeah, absolutely. You can import Fortify files. In Axway, we also run Fortify Software Security Center. So we have a central repository for all of our static analysis results. We built a Fortify SSC to Threadfix connector that we're going to be contributing to the open source community first quarter next year.
Yeah, this would be really useful.
Yeah.
What about Coverity? Coverity. It's
Coverity.
Coverity, yeah.
To my knowledge, I don't believe it's supported yet. Coverity, I believe, is a web service, right?
It's also a static scanner, but used mainly for C or C++.
It supports a number of scanners, Veracode, IBM AppScan, Fortify, etc. I don't know if Coverity was one of them. You can always give the guys over at Denim Group who created Threadfix a call, send them an email. If you want to write one yourself, they are glad to accept contributions. Axway has actually contributed quite a lot to this project. So.
Okay, thank you.
Thank you, everyone. If you have any more questions, I'll be at the back. So thank you.